All right, so the final bit of this, we're looking at the shortest distance between two lines. So we've looked at the relationship between different kinds of lines, and we're now looking at finding the shortest distance between them. So the first set is intersecting or coincident lines. So if you find a line is intersecting or coincident, the shortest distance between them would be 0. They have a point where they intersect, which means 0 distance. If we go to parallel lines, we have to find pretty much, as long as we find a point on a parallel line and we find a value that is perpendicular from it, no matter where we put this line. So if I do another line here, these are all going to be the same distance. So the idea being that, well, if we can identify a right angle, if we pick a point, we find a right angle to it, then we can do it. Now, we did this in a previous section where you find your point, you pick a point, on each line. This point is a fixed point. This point here moves. So you then would get, so R is moving along this line at the moment. So if we can get P to R dot product with B equals 0, then we're going to have PR is the shortest possible length it can be. Then we just take the modulus of that and get the length. Now, this is the most complex bit of the distance between lines in the shortest distance between skew lines. So the skew lines, like this diagram here, which is drawn, they don't intersect. So to find the shortest point between them, we actually find when there's a different line that is perpendicular to both these lines. Now, to do that, if we want A and B, we want to find this AB line. If we find the cross product of V and W, that actually means we find a certain vector that's got parallel components to this. And from that, we can find, so AB is going to be parallel to the cross product of this. AB is going to be a scalar multiple of this. So what we do is we find these particular ones. So in the example here, find the shortest distance between skew lines. I've drawn these out in the vector. So we've got our direction vectors here. So one direction vector, a second direction vector. So our AB, just going to use this value here. So we're going to find V cross W first. So we haven't actually done this for a little bit. So I'm hoping you guys remember, because it's actually been a couple of weeks. So negative I, negative J, K. And then our first direction vector here is 1, -1, and 1. So you'll notice they're the other way from how we were operating. And then our other one here is -1, 2, and -1. Oh. Now, you can put these in the calculator and get these out straight away. So I'm going to solve it just as a reminder, but we can actually do these. So this first one is going to be -1, 1, 2, -1. And part of the reason I'm doing this is good practice for just making sure you're quick at these, and it's how we check it. 1, 1, -1, and -1. So remember, we're covering the one we're finding, and that gives us our other value. So now we're on to our last one, which is going to be our K, which is going to be 1, -1, -1, and 2. And that gives us our K component. So we've got here -1 times -1 minus 2 times 1. So we've got to remember that we're looking at the determinant of these two things, which is, I'm just going to write it down here. The determinant of a vector is AD minus BC, which we're doing. So these values here are going to be I. We're going to then have minus 1 times -1 minus 1 times -1. And this is going to be our J component. And then our K here is going to be, I'm going to have to get a bit smaller, 2 times 1 minus -1, -1, and that's going to be K. Okay, and a big bracket there. So this, I should have slid this over further. So I could have written it with more space. I might clean this up after our video. Okay, so this is going to give us -1, so +1 minus 2. We're going to have -1i, and then we've got -1 minus 1 is going to give us 0. So we've got -0j, and then plus 2 times 1 is 2, minus -1 times -1 minus 1 is going to give us 1, and that's going to be k there. So we've got this vector here. So this vector here would be -1, 0, and 1, just changing it to the format. And that is, remember, that was our cross product vector there. So we've solved that one there. So we've got A and B points on the skew line. So we've got this vector here. So this AB vector here, so I'm going to go AB equals K V cross W, so that's the cross product we just did, means that this vector here is some multiple of K times -1, 0, and 1. Okay, so that's what our AB is looking at the moment. Now this A value, depending on which skew line we want to put things on, we're looking at A here is going to be, so A is this coordinate here, and we've got A, let's say that A is on our first line. It's going to have the coordinate T, and then 1 minus T, and then the final coordinate here would be 2 plus T. And this B, so that was from 0, 1, and these components. This other one, B here, is going to have a coordinate of 3 minus S, -1 plus 2S, and 4 minus S. Okay, so A and B is going to be, we've got those components there. So if I've got room, where am I going next? Let's go below it. Okay, so we've got here, from that notation there, I'm going to have to just draw a shorter room here, which is a little bit annoying. So therefore, A to B is going to equal our B coordinate, which is going to be 3 minus S, -1 minus 2S, and then we've got 4 minus S. Okay, and then we're going to minus, minus, minus. We now put our A coordinates in, which is T, 1 minus T, and then 2 plus T. Okay, and now I'm putting them all in brackets just so we don't get them confused. So let's simplify this down. This is going to be 3 minus S minus T. This one here is going to be -1 minus 1. So we're going to have -2 minus 2S plus T.
Well, it's not, guys, it doesn't go on a report.
Yeah, and our next one here, we got 4 minus 2 is 2 minus S minus T. Okay, now we've got to remember that this vector here, which we've just calculated, is equal to the scalar product of our cross product. So it's going to be equal to K, -1, 0, and 1. So we're going to have 3 different equations here, which is going to mean that we've got 3 simultaneous equations because we've got 3 unknowns. So we're going to have 3 minus S minus T equals -K. We're then going to have -2S plus T equals 0. We're then going to have 2 minus S minus T equals K. All right, now, because these K's are different signs, we can do this straight off the bat. and we can solve this. We are actually going to develop these skills a little bit more. So we will just do that. We will add 1 and 3 together. So using 1 and 3, we get 3 plus 2 is 5 minus 2s take 2t equals 0. And then we get, that's going to simplify down to 2s plus 2t equals 5. Okay, which is then, if we, so let me highlight this. So this, using 1 meant we use that one, and this one 3 meant we use that one, and they both gave us this one below it. And now if I take this one, what highlighter can I use to show that? We'll go this one here. If I rearrange this, I'm going to get another set of simultaneous equations, and all I'm going to do is I'm going to go, well, I've already got negative 2s, I've got plus t, and then if I add 2 to both sides, I get equals 2. So this would equal 0 plus 3t equals 7. And I must have stuffed up somewhere, negative 2s plus, I meant to have a negative. Because this gives me 2s. Why is that not right? 2s if I plus 2. No, sorry. These will be the same sign. So if I rearrange that, I get 2s plus t equals that. So I need to times that by negative 1. So I would times this by negative 1 times by negative, far out. I'm a bit all over the shop today. Yep. All right, sorry, all over the shop. All right, so this here needs to be times by negative 1, which will then give us, this would become negative 2s, negative t, and negative 2. So this would end up being 0. So I'm just going to put the negatives in front, like I've done that multiple. So 2s take 2s gives us 0. T take t gives us t. 2t take t gives us t. And then 3 take 2 gives us 3. So we get t equals 3. Now, this actually means that you can, now we've got t equals 3, you could actually figure out this point here. All right. And we just need to figure out what s is, which means we sub that into any of these equations here. Preferably this second one would be where I would go, and you're going to get, so from this, we then, I've got the highlighter again. You're then going to go, I'm picking this second one, negative 2, take 2s plus t is 3 equals 0. So that means 3 take 2 gives us 1 minus 2s equals 0. S has to equal negative a half for that to work. Negative 2. Yeah. 1 minus, minus 1. Why have I got that as positive a half? Negative 2 plus 2s plus 3. 1 take 2s equals 0, which is correct. Okay. So it should just be a half. Why have I got negative a half? Oh, I'm carrying this. Where did I get this? I've got a sign wrong here, I think. This is meant to be positive, which makes this positive, which makes that right. Okay, so that gives us the T and the S. So now we've got our AB, we've got two values here. So with our AB, we're going to copy that down, paste it down here. Oh. All right, and we figured out that S, I'm trying to figure out where I've got that value from. It's back up here, negative, we'll figure that out later. So we've got these values here. So we've got T, we've worked out that T equals 3, S equals negative a half. Okay, so we're going to sub those values in. So we get that AB here is going to be 3 minus negative a half plus take T, which is going to mean take 3. We've got our next one here is negative 1. For some reason I've got this negative 2. I must have stuffed up all the way back up here. Negative 2, where did I get that? I've carried it wrong from here, so I do apologise, which means, yeah, I've carried that through wrong most of the problem. So plus 2, S was negative a half, and then minus 1 minus 3, which means we get to 2 minus negative a half minus 2 plus 2 plus 3 minus 2 plus 3. So that's going to be, so this is going to end up being, I'm just going to skip through this. This is going to be a half, this will be 0, and this will be negative a half, which gives us, this is our vector now. This will give us our vector from A to B here. And so now we will just figure out the length of this, and we would just use the norm in our calculator and do this vector a half, 0, negative a half. Okay. And we get matrix math matrix vector option matrix vector norm, and our math matrix vector 3 by 1 divided by 2, just putting the fractions into the calculator now, negative 1 over 2, and we get 2 root 2. So it's 2 root 2 root 2 on 2 units long. Therefore, the shortest distance between the lines is 2 root 2 units.